the Pythagorean Identities, kind of relate to a few things that we've seen before. So first off, how about the unit circle? Kind of just draw the first quadrant. We're going to use the first quadrant, but it kind of keeps on going around. The equation for a circle, if you remember, is x minus h squared plus y minus k squared equals r squared. So we have this circle. In this case, when we do the unit circle, our center, hk, is 0, 0. So it ends up just being x squared plus y squared equals, when we have the unit circle, remember the unit circle has a radius of 1. So this would equal 1. Now on the unit circle, in terms of all these different points, how we represent them, like let's say right here, this is 30 degrees or pi over 6. This would be the point root 3 over 2 comma 1/2. Okay. If you remember how we use these is the x value is always the cosine of theta, and then the y value is the sine of whatever the angle is. So when we replace, instead of x squared, so x squared plus y squared equals 1. So instead of x, if we replace it with cosine of theta plus y is sine of theta, we are going to get the Pythagorean identity. Notice too, it kind of goes back to if we made this into a triangle. This is our x value, our y value, this is 1, Pythagorean theorem. X squared plus y squared equals 1 squared. Just again though, relating back to the x value is cosine, the y value is sine. So this is the Pythagorean identity. How we usually see it though, notation wise, so that we don't have to use parentheses. We wouldn't want to just put squared at the end though, because then it looks like the angle is being squared. So notation wise, this is cosine squared theta plus sine squared theta equals 1. So this is the notation we use when we're squaring trig functions, but this is what it means. It's the whole thing, whatever the value is, squared. Notice too, a lot of times you would actually see this as sine squared theta plus cosine squared theta equals 1. Usually we'd put the sine first, but same thing. Let's kind of prove that. Let's pick this point out and see that it works. And this is, I can pick any point on this circle, not even just the ones we usually see on the unit circle. Any little point, you know, at like 5 degrees, at over here, negative 100 degrees, doesn't matter. But let's just, since we already have this point down, let's do 30 degrees, or pi over 6. So the sine value at pi over 6 is 1/2. Okay, we're just punching sine of 30, that is a half. So this is 1/2 squared plus cosine the x value is root 3 over 2 squared. Let's use some parentheses. So let's see if that equals 1. 1/2 times 1/2 is a quarter. Root 3 over 2 times root 3 over 2, that's going to be 3 on top. 2 times 2 is 4 on the bottom. Yep, 1/4 and 3/4 is 4/4 is 1. So that'll happen, that'll work out no matter what angle we pick, like I said. Okay, so I'm going to make a little more room. Talk about I'm going to talk about this a little more. I'm going to rewrite sine squared plus cosine squared equals 1. So first off, I just want to point out that different variations of this are going to be used quite a bit. So let's say I want to have sine squared alone. That would be the same as move the cosine over. So we'd have 1 minus cosine squared theta. Or if I wanted cosine squared theta alone, move the sine squared over, 1 minus sine squared theta. So we might use all 3 versions of those at different points. The other thing I want to do, start over. Let's say, again, start with sine squared theta plus cosine squared theta equals 1. Okay. So this one is sine and cosine, but then there's similar ones that deal with tangent and cosecant, secant, cotangent. So how we get those, let's look at this. If I divide everything by sine squared, divide both sides by sine squared, I can do that since I'm doing it to both sides. So let's see what happens. Sine squared divided by sine squared is 1. Cosine squared divided by sine squared, I mean this, if we took away the squareds, cosine divided by sine is cotangent. So this is going to be cotangent squared theta. And then 1 divided by sine is cosecant squared theta. So this is another Pythagorean identity, but in terms of cotangent and cosecant. So, and again, they can be rearranged. We can have 1 equals cosecant minus cotangent, cotangent is cosecant minus 1, move it around. There's 3 versions of it. And then let's get one more. So just like here, I divided everything by sine. If I divide everything by cosine, I am going to end up with sine divided by cosine is tangent. Tangent squared theta plus 1 equals 1 divided by cosine is secant. So secant squared theta. So I get another one of my Pythagorean identities. So the kind of basic ones are 1, 2, 3 of them.